In many videos, I say that if you give me a dataset with, let's say, 1 million rows, not necessarily I will find value in it, statistically speaking. In this video, you will see the opposite case. We have, let's say, a decent amount of rows, but a lot of columns. And generally, I say that you have to find more columns for your phenomenon of interest if you want to be able to explain your target variable. This person wanted to find the net legal balance or the net legal revenues of 230 schools. And even though they had more columns than rows, we start immediately with a problem. That is something that in many videos returns. That is, here we don't have a target variable that has a normal distribution or bell curve, if you prefer, but an exponentially negative distribution. And that is, once again, very common when we deal with economics data. When you deliver such target variable, one of the first thing the statistician must do, otherwise you have somebody that didn't complete their training, is to do a transformation of the data. Here you see that I did the log transformation, and after I did it, I checked it actually looked like a normal. The answer is yes, it looks more like a normal. If we try to explain the net legal balance transformed like that with the many columns the person provides, we see that we explain at most 50%. That is not a satisfying results. As you can see, I ran some correlations as a previous step. We have some significant correlations, but even though they look high, with this model we can't explain more than 50%. I say this because in the dataset we have over 300 columns, and one might say, surely with such amount of columns you can build something that explains over 90% of the target variable. That was the request of the person, and that is no. Also, if you try to do the correlation with the non-transformed variable, you have similar results and a model that explains almost 70%, but again, adjust that squared or the percentage of variability that you explain, it is one key performance indicator of a statistical model, not the only. If a person wants to impress you, surely they just show you that and not the diagnostic of the model. So, as a summary, in this video you saw that we had a rare case. We had more columns than rows. Fortunately, the columns belonged also to what I call internal data and didn't have a predictive power. Also, we had a target variable not normally distributed, so we had to transform it, and even though we transformed it, we couldn't fulfill the request of the person, that is, having an accuracy higher than 90%. This experience will help you to understand the importance of data quality, in this case column quality, since we had many. Of course, you could say that with a different model or with hyper-tuned variable, as they call it, that is, for example, taking the log of this one or all the transformations of the axis, I could have improved the performance. Yes, but I don't expect to reach the value of explained variance that the person wanted. If you have a similar case, we can first discuss it in a free call so we can avoid potential surprises. You can book the free call in the link you see in the description. Bye and see you the next time.